Good morning, everyone. My name is Sujata. I work for the Alumni and Corporate Relations Office, and it is my pleasure to announce this program, the book launch, Developments in Photoelasticity, a Renaissance. We will begin with the Tamil Thai Varthu.
வெக்கணமும் அதில் சிறந்த திராவிடர்கள் திருநாடும் தக்க சிறு திரை நுதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனே
We will follow this with an invocation sung by Ms. Kartika Santosh. I would now like to request our Dean, Alumni and Corporate Relations, Professor Mahesh Panchangula, to give the welcome address.
Thank you, Sujata. Good morning, everyone. Good evening and good afternoon to those joining from outside India. It's a delight and pleasure to welcome this group to this book launch event. It is, as one of my colleagues remarked, it's a digital book, and we are doing the launch digitally, which is quite befitting of the way we've been operating for the past couple of years. Professor Ramesh has been a pathbreaker in this space of writing books, not just books, but books in interesting formats, in formats that are somewhat more futuristic, somewhat more ready for absorption by the next generation of students, which is something that I've admired in him. I would also like to welcome Professor Wang and Professor Mello to this book launch event, which is always it's always a delight to have our collaborators join us for an event like this. Also want to extend my personal invitation to Krishna, who's been a good friend of IIT Madras and has been a well-wisher in many ways, giving us thought directions and also helping us kickstart some of our very important and key initiatives. I want to also take this opportunity to invite all of you to come back to IIT Madras. We are now open for business. The 2 years of COVID are behind us. I also want to suggest that today's IIT Madras is very different from the one you saw, even a few years ago. So those of you that have not been on campus for some time, please join us. It'll be our delight and pleasure to welcome you all on campus. With those few words of welcome, I would like to hand the mic back to Sujata and look forward to the rest of the launch event. Thank you.
Thank you, Dr. Mahesh. I would now like to request Professor Ramesh to introduce Professor S.R. Sirohi.
I have great pleasure in introducing Professor Rajpal Singh Shirohi. He was formerly a professor of physics at IIT Madras, director IIT Delhi, served as vice chancellor for several universities, and currently a senior professor at Alabama A&M University, USA. He is a fellow of several important academies and societies in India and abroad, and is listed within the top 2% of the global scientists in optoelectronics and photonics. He has 250 journal papers to his credit and has published 13 books, including 5 milestones for SPAE under the roles of author, co-author, and editor. Professor Shirohi has received several awards. To name a few: recipient of Padma Shri for the year 2004, Galileo Galilei Award of International Commission for Optics, UNESCO Albert Einstein Silver Medal, Gaber Award by SPAE, Sir C.V. Raman Award, Homi J. Baba Award from UGC, and 2022 SPAE Maria J. Usual Educator Award. Professor Shirohi has sent a video, and this will be played for the audience.
Good morning. My name is Rajpal Sirohi. I am the series editor of the series Optics, Photonics and Optoelectronics, published by Institute of Physics, UK. Under this series, we publish books on optics and related topics. I knew Professor Ramesh when he was professor at IIT Kanpur, and I was professor at IIT Madras, and we used to correspond. I knew that he has published a monograph on digital photoelasticity, published by Springer Verlag in 2000, and I also watched NPTEL lectures given by Professor Ramesh. Having known him for so long and familiar with his work, I requested him in 2019 to write a book on photoelasticity, and he kindly agreed. The book, with the title Developments in Photoelasticity, A Renaissance, was published in October 2021. It has 5 chapters. Chapter 1 deals with the fundamentals of photoelasticity and photoplasticity. Chapter 2 contains methods to enhance sensitivity like fringe multiplication, fringe shortening, fringe thinning, and so on. Chapter 3 is on phase shifting techniques, which became very relevant when CCDs are used for recording. The output can be presented almost in real time. 4th chapter is total fringe evaluation, uses white light photoelasticity. And the 5th chapter contains varied applications of photoelasticity in different disciplines. The book has come out very well. I also requested him to include a large number of problems so that the students can benefit. He kindly agreed. The book therefore has lots of problems and very recent references of the work in photoelasticity. The book therefore has appeal to both the researchers and the students. If you go through the preface of the book, you will know a lot about the author and about the contents in the book. Professor Ramesh is a teacher par excellence, a very well recognized researcher and humble man. I congratulate him for doing this excellent job. I am also very happy to take part in the celebration of the release of the book. Thank you very much and God bless you all.
Thank you, sir, for playing that video. It is now my pleasure to introduce Professor Wei-Chung Wang. Professor Wei-Chung Wang is a senior professor in the Department of Power Mechanical Engineering of the National Tsinghua University. He is the fellow and the former president of the Society for Experimental Mechanics, SEM. He was an advisor for the Ministry of Economic Affairs, executive director for the Zhejiang Foundation of Science and Technology, and director general of the Department of International Programs of the National Science Council. Currently, Professor Wang is a senior advisor for global affairs and director for the Center for Indian Studies, a great friend of India. And during the second COVID wave in India, through his initiative, IIT Madras received 10 oxygen concentrators for distribution in India, contributed by the alumni of NTHU. Professor Wang is a recipient of several awards. To name a few: Pericles Theocharis Award instituted by Eurasem, Zanman and Tacknell Awards of SEM, and Frost Award designate of SEM for the year 2022. I would now like to request Professor Wang to address the audience.
Thank you very much for the brief introduction. And ladies and gentlemen, good morning and good afternoon. And thank you for the invitation from Professor Ramesh for the book launch. It's my great pleasure and honor to be here. In fact, I have been a loyal reader of Professor Ramesh's books. I purchased all his books published, like an e-book on fraction mechanics, experimental stress analysis, digital photoelasticity, also including his software, P-Scope, recently on the market. Even I haven't had a chance to use it, but we will use it very soon. I have admired him because his diligence and wisdom on the work of his photoelastic work. I still remember that when I was a PhD student in the United States from 81 to 85 in Iowa State University, by that time, finite element also almost killed photoelasticity. People thought with the finite element, we don't need photoelasticity anymore. Fortunately, with the invention of the image processing, with the technology transfer from NASA to the ground, for my PhD work, I used the first generation image processing system. By that time, it's like a refrigerator. When I returned to Taiwan in 85, it becomes a simple, small interface card because of the rapid growth of the semiconductor industry. And now, the chip becomes even smaller every year. So I think with the advancement of industrial equipments and the technology, photoelasticity will never die. It will keep growing, like what's shown in Professor Ramesh's new book, Renaissance, the developments in photoelasticity. I read the book very briefly. I was so amazed with the contents because it's not only give a very clear statement on basic principles for the benefits of young generation, but also introduce many potential applications of photoelasticity. I myself have some interaction with Professor Ramesh in the past 20 years, with his students too, because we have common interest on thermal stresses, fractal mechanics. By reading the book, I can read so many brilliant development from his lab. It's amazing because his wisdom and deep understanding of the principle of photoelasticity. I think the book will become a very, very important reference book, textbook for everyone working in the experimental mechanics community. Please accept my sincere congratulations, Professor Ramesh, for your great achievement. Thank you very much. And everyone, please stay healthy and safe. Thank you.
Thank you very much, Professor Wang. I'd now request our Dean, Professor Mahesh Panchangula, to introduce our chief guest, Sri Krishna Mahesh.
It's a delight to introduce Krishna to this audience. Krishna is the MD of Sundaram Brake Linings and the founder CEO of a very interesting company in medical devices, the Sundaram Medical Devices Private Limited. He has an MBA from Harvard Business School and a BS and MS in mechanical engineering from Stanford. He was the winner of the first HBS alumni new venture contest that actually resulted in the creation of Sundaram Medical Devices. The focus has been to leverage the engineering rigor and production discipline of the automotive industry to bring low-cost manufacturing thinking to the medical device space while delivering high-quality products that suits the patient and the caregiver, as I said, at an affordable price. As a business analyst with McKinsey, he led client teams in the automotive and healthcare industries in areas such as operational improvement, strategic price leadership, and new product platform strategy development. He has also made valuable contributions in operational improvement and business management of various North American plants while working for Toyota Motors. His family has instituted the K. Mahesh Chair Professorship at IIT Madras in 2020, of which Professor Ramesh is the current occupant. It's a delight to always meet Krishna, and we look forward to hearing from him. Thank you.
I would now like to request our chief guest, Sri Krishna Mahesh, to launch the book. The book will be shown on screen by the panelists as well, who have copies, please.
So, thank you, Professor Mahesh, for that very kind introduction. I think coming from industry, our common refrain whenever we deal with academics is, yes, that's all very interesting, but how is that applicable? I think Professor Mahesh's book is a tour de force in not only saying putting out the material that's interesting, but also how it's applicable to industry. Coming from two fields, both automotive as well as the healthcare sector, where serving billions of people is a goal of all of these industries, and we're driven therefore by constant cost pressure. The ability to use novel techniques, non-destructive, reducing waste, and to be able to understand static, dynamic, and shock loading and its impacts on the various material we use is not only useful, but can be revolutionary as we move forward in this increasingly digital world. Everyone knows that industry is moving increasingly towards a digital prototyping culture to increase both speed and reduce waste. And I think Professor Ramesh's book provides a good starting point for all of us to be inspired about ways we can go ahead and use these techniques that have been developed in the decades past, but rejuvenated by modern technology to actually provide input to the most modern thinking in industry itself. And I really thank Professor Ramesh for putting out this wonderful book. It has always been a pleasure to meet him, and it continues to do so. And I hope we will continue to have these opportunities for many years in the future to come. Thank you once again, Professor Ramesh, for this wonderful book.
Thank you, Mr. Krishna. I'd now like to request Professor Arun Menon to introduce our director, Professor V. Kamakoti.
A very good morning to one and all. It is my honor to introduce our director, Professor Kamakoti Veeranathan. Professor Kamakoti Veeranathan received his MS and PhD degrees in Computer Science and Engineering from IIT Madras. He joined IIT Madras as a faculty member in 2001 and took over as its director in January 2022. He specializes in computer architecture, information security, and VLSI design, and heads the microprocessor development program and the information security education and awareness program at IIT Madras. Professor Kamakoti was the chairman of the Artificial Intelligence Task Force and is a member of several committees such as the National Security Advisory Board, National Stock Exchange, and Reserve Bank of India. He has over 150 publications to his credit and has handled so far 50 projects from the industry and government R&D establishments. Professor Kamakoti is a recipient of Abdul Kalam Technology Innovation National Fellowship, DRDO Academic Excellence Award, Indian Electronics and Semiconductor Association Techno Visionary Award, ACCS Lifetime Achievement Award, IBM Faculty Award, and Vasvik Industrial Research Award. Thank you. Over to you, Sujata.
Thank you, sir. I would now like to request our director, Professor Kamakoti, to address the audience.
Thank you, Arun, for the introduction. Thank you, Professor Ramesh, for inviting me for this wonderful book launch function. I'm very excited to see the development, specifically in this area of photoelasticity. What is really striking is a set of applications that you have listed. It all starts from plant biology all the way to semiconductor packaging. And what is very interesting here is your very important aspect of what we may term as reverse engineering, right? What happens inside a furnace can be calculated in some form which cannot be directly measured. I think this is going to be completely a different game changer when put into practice, and I'm sure many students will take this up as a career, and we would like to see many startup industry coming which uses these techniques elaborately and with lot more precision to bring in a big change in the area of manufacturing so many of these components. I think in that way, this is an excellent book, and I'm sure, as I know Professor Ramesh, he practices before he preaches, and I'm sure he should have started a course in IIT Madras in this area, and the experience that you had gained in teaching those courses, I think has come out, has been very clearly reflected in this book. Again, congratulations, and very happy to be part of this launch function. And this is the first book that I'm just seeing after I took over as director. It's a very good start. Thank you for that also. With this, I congratulate you again, and I congratulate the series. Right, I think this should be fourth or fifth in the series of advances in optics, photonics, and optoelectronics. So Professor Sirohi has been the person who has been driving this, and I'm sure there'll be many books that come out in this series. I also thank Professor Wei-Chung and Professor Mello for being here for this book launch, and our chief guest, Mr. Krishna Mahesh. With this, I hand it over to Sujata. Thank you very much.
Thank you, sir. It is now my pleasure to introduce Professor Michael Mello. Professor Michael Mello is currently a teaching professor of mechanical and civil engineering at CalTech. He was formerly a senior electronic packaging engineer at Intel from 1997 to 2006, where he founded and managed the company's premier photomechanics laboratory. His research interests and publications span the areas of electronic packaging, earthquake rupture dynamics, optical interferometry, and shock physics of condensed matter. He serves as the Associate Technical Editor for Experimental Mechanics and has received a number of awards for his exceptional teaching. The awards include the M.M. Frost Award of SEM in 2021, the ASCIT Teaching Award, Northrop Grumman Excellence in Teaching Award, Outstanding Faculty Award, the Donald Coles Prize, and the Intel Achievement Award. I'd now like to request Professor Mello to address the audience.
Greetings, everyone. It is my honor and pleasure to be invited to this book launch. I have long been a fan and admirer of Professor Ramesh. We have corresponded, but I believe this is the first time that we have actually ever met face to face, and it is my pleasure to meet him in this way this evening. When I say I have admired and followed Professor Ramesh, I mean that I have discovered him through his books, Digital Photoelasticity, which resides on my bookshelf in my office, which I have gone to many a times, and in fact admire as, I would say, the leading reference on the use of phase shifting techniques in elasticity. One can find references to phase shifting methods anywhere, but in no book that I have ever found have I ever found phase shifting elasticity methods so clearly digested and described as I find in his books. And again, we see that same theme duplicated once again in this current book, which we celebrate this evening, Developments in Photoelasticity, a Renaissance. I like the choice of the word Renaissance because those of us who use and admire and know these techniques keep them near and dear to our heart. And we also know that with the advent of new techniques, such as digital image correlation, many who are less familiar or who have less patience to understand the interference phenomena of these beautiful, elegant techniques like photoelasticity are quick to dismiss these techniques as old and perhaps less important. And of course, those of us here this evening and others who understand these methods beg to differ. We know and we celebrate books like this because they celebrate the legacy of this beautiful technique, and they show that it is far from being dead. It is in fact only being rediscovered by each successive generation of students. And to that end, having a book like this in e-form will serve next generations of graduate researchers very well as they explore the use of this technique. I mentioned phase shifting methods, which are well covered in this book, as they are in other books by Professor Ramesh. I also like and enjoyed reading the application to infrared photoelasticity. And I think in seeing that, I I think that connected with my roots in the semiconductor world, my time at Intel, where I came to understand and appreciate the value, the immense practical value of such techniques that could show stress singularities, which could show stress concentrations, which could show defects in rapid form. And so it was really a pleasure to see that as one of the applications highlighted in the book. So I've been asked to keep the comments brief. I will do that, but let me just conclude by saying, Professor Ramesh, bravo, congratulations. This just now is yet another addition that you have made, yet another seminal contribution that you have made to keeping this technique alive and modern, and in a form that will be rediscovered by generations to come. Thank you, and it's a pleasure to be here this evening.
Thank you very much, Professor Mello. I'd now request Mr. Ganesh to introduce Professor Venkitanarayanan.
I take this opportunity to welcome Professor P. Venkitanarayanan, who is a professor of mechanical engineering at IIT Kanpur. He is an expert in the field of experimental solid mechanics, dynamic fracture mechanics, high strain rate mechanics, and failure using optical techniques. Professor Venkitanarayanan was an associate editor of experimental mechanics and currently serves as the associate editor for the Journal of Dynamic Behavior of Materials. He is an excellent teacher and has received the Zanman Award for 2019 from the Society of Experimental Mechanics.
Thank you, Mr. Ganesh. I'd now like to request Professor Venkitanarayanan to address the audience.
Good morning to all those participants from India, and good evening to Mike and international participants. It's an honor and a privilege to attend this book release. I'm very thankful to Professor Ramesh for inviting me to this release, and also would like to thank IOP and Professor Sirohi for bringing out a book on the very classical technique of photoelasticity. As Mike mentioned, the word renaissance is very apt to this book, because I am a fan and a proponent of this technique. I got introduced to this technique by none other than Professor L.S. Srinath when I was doing my master's at IIT Madras. He was the director at that time. He used to take one class every week. Us, in spite of being a director and very busy person, and the class is still in front of me. He's such a good teacher that I can still visualize the way he writes his board and things like that. And Ramesh and I are in one way academic brothers in that sense. And I also am using the lab set up by Professor Ramesh at IIT Kanpur. He moved to IIT Madras. All those photoelastic models and all are still preserved and are shown to students. So this is one technique which can show you the stress field in a sample instantly to the students, and the moment you apply load and when they see the fringes, you can see the wow expression in their face. So this is a very apt book to be brought out, and like Mike and others told, many people believe that photoelasticity is something of the past and you can do everything with finite element. I disagree with that. With all respect to the technique of finite element, it can do wonderful job inside the domain, and when it comes to boundaries, there are a lot of questions asked, and Ramesh's book, the chapter on diverse applications, brings out the power of this technique to tune the boundary conditions to get good and reliable results. So one of the highlights of the book is the chapter 5, because many books discuss the technique, the nuances and things like that. But the practical applications discussed in chapter 5 should help students and other researchers to think beyond the conventional application of this technique. Of course, the other chapters gives very detailed description of the technique, the advanced methods used and proposed by many researchers and also by Professor Ramesh. But chapter 5 will give a lot of ground to students and researchers how you can extend the application of this technique, because I believe the scope of any technique lies in the ingenuity of the user. You can use it for any any application based on your imagination, and he has very nicely included topics ranging from plant root mechanics to residual stress measurements in lenses and so on. I have been associated with his laboratory as an examiner or a collaborator, and it's a pleasure for me to be a part of this book launch. And it's a very nicely written book. I had the privilege of going through the chapters in detail. I thank Professor Ramesh for letting me do that, because it was a learning experience and also an eye-opening experience. So congratulations, Professor Ramesh, and please bring out more books in these areas. And also we should take some effort to popularize this technique among engineering colleges. It doesn't take a lot of investment to set up a photoelasticity lab, and it is one of the best techniques which can give you real-time insight about stress analysis to students. With that, I again congratulate Professor Ramesh and close my talk.
Thank you very much, Professor Venkitanarayanan. It's now my pleasure to introduce Professor Arun Menon. Professor Arun Menon is an internationally acclaimed expert on the restoration of heritage structures. He has been involved in various conservation projects in India, Bhutan, Myanmar, and the Philippines. He was an expert member on the International Coordinating Committee, BICC, for the UNESCO World Heritage Site of Bagan, Myanmar, and currently is a member, Expert Advisory Group to International Conservation Committee for VAT4 UNESCO World Heritage Site in Laos, PDR. His research interests are in structural aspects of historical constructions, earthquake behavior of historical masonry structures, and earthquake-resistant structural masonry. He has more than 15 years of experience in the field of seismic engineering and historical monuments. He currently coordinates the activities of the National Center for Safety of Heritage Structures, NCSHS, a Ministry of HRD Government of India supported research center at IIT Madras. I now request Professor Arun Menon to address the audience.
Thank you, Sujata. It's a privilege to have this opportunity. Professor Ramesh, in his recent book, Developments in Photoelasticity, Renaissance, has actually revisited his earlier outstanding and rare contribution to the field of photoelasticity, namely digital photoelasticity, advanced techniques and applications. In the current effort, Professor Ramesh enriches it with 2 decades of continuing pioneering research and teaching in the subject, updating it with parallel developments in the field of digital techniques leveraged in photoelasticity to gain insights into a wide spectrum of research questions. This book assimilates fundamental elements, new developments, and scope for future research, dwelling on the physics and the mathematics of how fringe formation in a polymeric material is leveraged to study stress flow and stress field, setting standards for designing experiments, describing multiple techniques for effective data acquisition, extracting and processing, and integrating numerical modeling for validation studies. It is this rich and varied research experience embodied by the book that provided me an opportunity to scrutinize a problem often encountered in dry-jointed masonry, widespread in historical constructions, as observed by us at Sri Kedarnath Temple, among many others in the subcontinent. Reflection photoelasticity provided the possibility of new insight to this problem of localized propagation of cracking in stone units dictated by contact mechanics in the joints. Isoclinic information in masonry helps identify low deviatoric zones, which could be potential locations of destructive or semi-destructive tests, causing minimum disturbance to the load path. In another exemplar of exploratory research, digitally developed 3D printed photoelastic models to study the role of heterogeneity in concrete opens new possibilities for experimental and numerical analysis. In its last and yet most interesting chapter, the book reveals many such opportunities for applied research. Let me conclude by saying that Professor Ramesh's book in its new avatar, replete with color images, do require fundamentally to appreciate photoelasticity will serve as an excellent resource for exploratory, translational, and applied research to any open-minded seeker of scientific truth. Congratulations, Professor Ramesh. Thank you.
Thank you, Professor Arun. I'd now like to request the author, Professor Ramesh, to give us an overview of the book.
Thank you, Sujata. The book focuses on the renaissance of photoelasticity in the recent years. Digital photoelasticity advocates use of a generic polariscope, and this book recommends a 10-step method to evaluate the total fringe order and isoclinics. Usually, the researchers post-process these in a cumbersome manner for comparison with the numerical model. This book advocates a simpler approach by post-processing the results of a numerical model to get the total fringe order and isoclinics. With developments in digital photoelasticity, the book also advocates the use of a conventional polariscope with 4 steps to get total fringe order and isoclinic. On the other hand, use of a conventional circular polariscope with just one image for total fringe order evaluation, useful for solving time-varying phenomena. So the message in the book is, institutions that have the polariscopes can rejuvenate to digital photoelasticity with appropriate software rather than buying a generic polariscope at high cost. This shows an algorithm to find out the skeleton. This can be achieved from the software we have developed, DigiPhoto, and this shows a complex fringe pattern where you have white dots show the skeleton, and this is a crack. One would like to evaluate the stress intensity factor from this data. This is achievable by our another software, PSIF, and what you can do is you can extract data from this experiment, which was shown as red dots. As the number of parameters are increased, the red dots closely with the simulated fringe pattern. One of the applications of photoelasticity is in the development of jet engines. You have a dovetail joint, and when you look at a photoelastic picture, the joint stresses appear like this. In the contact zone, cracks can develop in service. They grow due to fatigue. One of these fringe patterns form the cover page of the book. We also have another software, P-Scope, for simulation using standard problems. This is for engineering education. One can also have carrier fringes in the simulation. Carrier fringes come in handy when you want to analyze a low birefringent material like glass. The carrier fringes augment the photoelastic information. You will be able to extract the data better, not only in the visual field, but also in the infrared region. Photoelasticity is applicable. This shows an example of a 3D electronic packaging with several stacks and a common through silicon wire that moves through it for connectivity. The manufacture of this introduces stresses which can be easily obtained using phase shifting, and the stresses are shown here. One can also, with the white light regime, we have a software called DigiTFP. Using this, we have analyzed problem of interacting cracks in an edge heated plate. It's a very challenging problem, time varying problem, and we have just recorded only one image and processed these to get the stress intensity factor. Not only this, the book covers a wide range of applications from our group as well as groups working across the world. This shows for a simple water bottle what kind of stresses developed at the bottom, at the rib region, and at the neck. This example shows what happens in a chain. In the colored fringe pattern, you have concentric circles, and in the black and white, you have a flowery pattern because of improper interference fit. Interference fit is not just hammering two mating components. In fact, the understanding developed in this study has helped an Indian industry to change their production line. Photoelasticity is also applicable for the analysis of seals. This came into prominence after the blast of Challenger. You have for the O-ring and various cross-sectional shapes, what kind of stresses that get developed. You all have a cell phone. Each of them have a camera. It's very cost effective, mainly because of precision glass molding without any further machining. The challenge here is the design of the mold and also optimizing that thermal cycle to minimize shrinkage as well as minimize stresses. The process is done in an enclosed environment. Heat transfer data is not possible to obtain. What is done here is the finished product is analyzed for residual retardation. This information is used to tweak the heat transfer properties such that the results match with the experiment. In fact, it is a very innovative approach, a game changer in precision glass molding. You also have interesting application on snake locomotion. Of course, people have used real snakes on non-poisonous ones. This is on a gelatin sheet. You have a snake. The black regions show where the snake has lifted its body. This information is necessary to model its locomotion. And once this is understood, it can help to create snake robo to rescue people entrapped in a rubber. You also have another application where an epidural injection is put. What should be the shape of the needle? How the stresses develop as the needle is pierced in. You also have another interesting application. What happens when the roots interact with the soil? As the roots grow, stresses develop on the soil. You have a simulation with granules simulating the soil. As time increases, the roots grow, they interact, and you see fringe pattern appearing on the grains. This knowledge is very important for food security because the modern day equipment compresses the soil more, which sends out a distress signal for the plant not to grow. So what you find here is, this is the true renaissance of photoelasticity. You have wide-ranging applications. I have mentioned only a few of them. And many of these applications have occurred in the last few years. Finally, photoelasticity is the technique to teach concepts of solid mechanics. Everyone is taught about beam under 3-point bending, and students are told shear stress varies parabolically. But what is not said is when it's very close to the load application point, stresses increase significantly and failure occurs in those regions. Surprisingly, this concept is not emphasized in the first level course of solid mechanics, and this is easy to illustrate by having a photoelastic equipment. Even if you don't have a photoelastic equipment, it's possible to simulate using our software P-scope. Finally, this book would not have been possible without the gentle persuasion of Professor Shirohi. And this book launch, the prime motivator for Mr. Krishna Mahesh, was very enthusiastic for its release. And I thank our director for chairing this session and our dean, Professor Mahesh Panchadmula, for introducing Mr. Krishna Mahesh. I also thank all the panelists, Professor R.S. Shirohi, Professor Wei-Chung Wang, Professor Michael Mello, Professor P. Venkitanarayanan, and Professor Arun Menon for giving insights on the book. I also thank all my project sponsors who have funded my research all these years. And my students, 5 of them, each one took 1 chapter of this book. And also my mechanic who made this models. And my thanks also to Ms. Sujata, VP Development, Mr. Kannan Krishnamurthy, Ms. Lisa Idil, Mr. Jawahar Babu, Media Cell, Alumni and Corporate Relations, and also the attendees who have attended it in large number and graced the occasion. I also thank all those who have directly or indirectly involved in this book launch function. My thanks go to all of them. Thank you very much.